Annapurna. With the help of the concept which we have built so far, is it possible to take out 1 by under root 1 minus x square? So let's check it. Suppose we are having y is equals to sine inverse x. Okay, and we have to find dy over dx. So we will see that on one side dy dx, on another side are we going to get this 1 by under root 1 minus x square? Let's check it. So we know that we can write this y is equals to sine inverse x is a sine phi is equals to x. Yes or no, Annapurna?
Yes.
Okay. Now if we will do differentiating both sides with respect to x, we can do so, right?
Yes.
Let's do the derivative with respect to x. So sine y will be
Cos y.
perfect. And here we'll be having anything else will be there.
Into dy by dx.
Perfect. And on the other side, what are we going to have, Annapurna?
1.
1. And dy by dx will be
1 by cos y.
1 by cos y. Now there is an identity which you know already, that is sine square x plus cos square x, that is equals to 1, right?
Yes.
The same identity can be used for anything like sine square theta plus cos square theta, sine square y plus cos square y. Okay, so for cos y, what can be written, Annapurna? What can be written for cos y? Suppose the same formula we are writing like this: sine square y plus cos square y. This formula is applicable for every, like for any angle, just the both the angle has to be exactly same. Okay, so yeah, this is what we are having. So cos square y can be written as 1 minus sine square y, right, Annapurna?
Yes.
And cos y can be written as under root 1 minus sine square y, yes or no?
Yes.
Okay, so plus minus sign will also come, but we are taking this scenario only. So we can write it 1 minus sine square y. And what is sine y? What is sine y, Annapurna?
X.
So from here, can you see we are getting dy dx is equals to 1 by 1 minus x square.
Yes.
Are you getting it?
Yes.
Now the next, let's do for tan inverse x. Okay, suppose we are having the same y is equals to tan inverse x. This time we are having y is equals to tan inverse x. We are having what to do at first, Annapurna?
Tan y equals x.
Tan y is equals to x. And if we will do differentiating both sides with respect to x, what are we going to get?
6 square y into dy by dx equals 1.
Dy by dx will be 1 by sec square y.
Yes.
Perfect. Then we can write it in terms of tan, right? This sec square y
Yes.
is there. This identity we must use over here. What are we going to have?
1 plus tan square y.
What is tan y?
X.
So from here we are getting dy by dx is equals to 1 by 1 plus x square, which we always use, right?
Yes.
Okay, so from like this only, these are the formula has been derived like this only. Why not we were doing it previously? because previously this chain rule was not known to you, right?
Yes.
Okay, let's continue. Suppose we are having y is equals to cos inverse 1 minus x square over 1 plus x square, and we have to find dy dx over here. What to do over here, Annapurna? Yes, how to find dy dx?
Take cos inverse x.
Can we apply chain rule over here?
Yes.
Yes, we can apply chain rule. Just a second. But that we are not going to do. Why? Why we will not do? Because by chain rule, the formula for cos inverse x is. Can you tell me what is the formula for derivative of cos inverse x?
Minus 1 by root of 1 minus x square.
Perfect. This formula, what is x over here? This complete is x. That is square we will do. And then again we have to do the derivative of this one, right?
Yes.
And simplification also we are supposed to do. It will take a lot of time to do this much of like huge simplification. That is one of the way. If you are not getting what to do, please do it by chain rule. At least you will be getting full marks for that. But here we can also apply the logic of inverse trigonometric function. That is, we can simplify this part at first. How to simplify? What can we assume as a x over here? Sin theta, cos theta, tan theta,
Tan
cot theta,
theta.
tan theta. So we are having 1 minus tan square over 1 plus tan square. Is there any formula for that?
Cos 2 theta.
Okay, cos 2 theta, cos inverse, cos 2 theta. So we ended up getting just 2 theta, right, Annapurna?
Yes.
And what was theta? What was theta?
Tan theta.
What is theta? Just theta.
X.
If I will ask you to isolate theta, keep theta on one side, theta will be,
Cos x.
can we write from here, theta is tan inverse x, can we, Annapurna?
Yes.
Let's use it. So we were having this type of function which like at first initially we felt like if we will apply chain rule it will take time. Okay, and time is precious during exam. We must utilize properly our time. So we saved our time by doing this 2-3 step and we are done. Okay, now we will do the derivative of this 2 tan inverse x. So it will be dy dx is equals to derivative of tan inverse x is 2 by
1 by 1 plus x square.
this one, right, Annapurna?
Yes.
Perfect. Let's do the next one. Suppose we are having y is equals to tan inverse 3x minus x cube over 1 minus 3x square. Okay, again, still we have to find dy dx. Okay, what can we? One of the ways chain rule, but that will be huge and time taking also. So if there is any substitute, any other rule is there which can be applied over here, we'll be using that. So yeah, in inverse trigonometric function simplification you have learned that can be used over here. So what can be taken as a x, Annapurna?
Tan theta.
Perfect. X is tan theta, and if you will substitute 3 tan theta minus tan cube theta 1 minus 3 tan square, what are we going to have, Annapurna?
Tan 3 theta.
Tan 3 theta. So tan inverse tan 3 theta, that will give just tan inverse of tan is
3 tan inverse theta.
okay 3 theta, that is 3 tan inverse theta or x.
X.
Let's do the derivative of that 3 by 1 plus x square, right?
Yes.
Done. Let's do the next one. Suppose we are having y is equals to sine inverse 1 minus x square over 1 plus x square. What to take as a substitution? Annapurna.
Tan theta.
Still we'll be taking tan theta. So 1 minus tan square theta by 1 plus tan square theta is what?
Cos 2 theta.
Cos 2 theta. But here we are having sine inverse. What to do? What to do over here, Annapurna?
Convert cos to sine.
How? How?
Cos 2 theta is cos pi minus
Cos pi minus theta. That is minus cos theta. Cos pi plus theta. That is also minus cos theta. What to take?
cos pi by 2.
Cos pi by 2 minus theta we can take. Here cos 90 minus theta, pi by 2 minus theta is just, we are writing cos, we must write sine, right? Because it's not making sense, right?
Yes.
We must write sine pi by 2 minus theta. That is just cos theta. So at the place of cos theta, we can write sine pi by 2 minus theta. Why we are doing so? Because we are having sine inverse over here. Now sine inverse and sine will neutralize each other, and we will end up having pi by 2 minus 2 theta. What is theta?
Tan inverse x.
now you will be able to continue. The derivative of pi by 2 Annapurna is
0.
let's continue. If suppose we are having cos inverse 2x over 1 plus x square, then what to
Uh,
take?
con- Convert x into tan theta.
Tan theta by 1 plus tan square theta will give us,
Sine 2 theta.
and we can convert it in cos. Okay?
Yes.
And what about this one? What to take as a x over here? What to take? Annapurna.
Sine.
If we will take sine, let's check whether it will work or not. Work Annapurna? That what
No.
will be there? Yes or no?
No.
Under root 1 minus sine square theta is what?
Root of cos theta.
Just cos
Co-
theta or cos
no,
square?
cos square theta.
Come out as a just cos theta, yes or no?
Yes.
Will it work? Will it
Yes.
work? Yes, it will work. Okay, sine 2 theta formula we can see over here. So we don't even have to think about changing the angle or just writing it like the previous case when we were using sine 90 minus sine pi by 2 minus theta cos pi by 2 minus theta. That also we don't have to do. Directly we got sine inverse with sine. Let's continue. Sec inverse 1 by 2x square minus 1. What can be taken over here? Yes.
Tan.
Be taking tan will it work? 2 tan square. This 2, if 2 will not be there, no, then we could have done anything. But here this 2 is there. Even if we will take sine, sine 2 sine square theta. No. If we will take cos 2 cos square theta, is there any formula? No. Is there?
No.
If we will take tan theta, 2 tan, cot theta, 2 cot, just because of this 2 we are not able to think. Okay, and we cannot do anything with this 2. So what can we do? We are having y is equals to this one and we have to find
Using chain rule.
chain rule. Yeah, that is one of the options that we can use chain rule. Second verse we can find the derivative and then this 1 by 2x square minus 1 that we can find. Yeah, that is one of the options. The savior method, that is chain rule, when we are not getting anything, then then the chain rule can be applied. Let's see whether it is too difficult to use chain rule or not. Here in your book, clearly, if you are having your book, what is the derivative of sec inverse theta?
1 by x into root of x square minus 1.
Okay, so before using chain rule, let's think about what can be done. What else can be done? So can we write it as a dy dx? We have to find the way we did previously. Sec y is equals to 1 by 2x square minus 1 to the right. We try doing the derivative now. It help. Let me check. Yeah, just a second. Let me check it on pen and paper. Here we can, if we will try 1 by 2x square minus 1, this is UV rule. And if we will apply the quotient rule, just this one is becoming huge. Otherwise, this approach we could have taken, right, Annapurna?
Yes,
Okay, you can see that in UV rule when the denominator is already this huge, 2x square minus 1, and when we will be applying this u by v rule, then we have to do the square of the denominator, right? V square in the denominator.
yes,
So again it will, already it's huge, it will be more. So just a second, if we will convert, if we will take the reciprocal, will it help? Just a minute, let me check. 2x square minus 1 equal to, and sec y, if we will take the reciprocal, 1 by sec, that means cos y is equals to 2x square minus 1. We can find the derivative of this. Before doing this much of thing, just a question. Here is a rule like this. Now I'm realizing that there is a rule like this, right? Which rule? Which rule? Cos 2 theta is having three formulas, right?
yes.
Basic three formulas. What are those?
Uh, 2 sine theta cos theta.
First one is cos square theta minus sin square theta. Yes or no?
Yes,
Okay. Next one is 1 minus 2 sin square theta. Right or no?
yes.
Next one is,
1 minus tan square theta by 1 plus tan square theta.
what about this formula 2 cos square theta minus 1? Is it there? Is it there?
No,
Now we are saying that cos 2 theta formula is cos square theta minus sin square theta. Do you agree with me that this formula exists? Yes or no?
Yes.
Here, if we will convert this sign as a cos, it will be 1 minus cos square theta. Yes or no?
Yes.
Cos square theta minus 1 plus cos square theta. Can you see a 2 cos square theta minus 1 is the formula. Recall that whenever we were having 1 minus x by 1 plus x in the previous class we were doing, we have used the cos 2 theta formula. We have taken x as a cos theta and we said 1 minus cos theta by 1 plus cos theta. And then we have done the conversion like this. In the numerator we have used the sine formula, that is 1 minus for cos theta. Let's take one. Okay, x is 2 theta. X is cos 2 theta. X is cos 2 theta. So for the numerator part, we have used the sine formula, that is 1 minus sine square theta. 2 sine square theta, right? Right.
Yes.
This formula. And then in the denominator, we have used the cos formula, that is 2 cos square theta minus 1. Yes or no?
Yes.
So this formula exists or not?
I just remembered this formula, yeah.
Yeah, this formula exists. Okay. So if this formula exists, then why we are doing that much of hassle? Okay, 2 cos square theta minus 2 cos square theta minus 1 we could have taken initially only. We were having y is equals to sec inverse 1 by 2x square minus 1, and we were thinking what to take as a x, and we realized that nothing is working, but now only we realize that cos 2 theta formula is here, that is 2 cos square theta minus 1. Okay, so if at the place of x we will take cos theta, just cos theta, we are able to generate the formula. Yes or no, Annapurna?
Yes.
So we are getting here second verse 2 cos square theta minus 1 is cos 2 theta formula. 1 by cos 2 theta is sec 2 theta, right?
Yes.
Right?
Yes.
Theta. Theta is cos inverse x. Theta is cos inverse x. And we will easily be able to find dy over dx. Now the simplified version of y is this, and we can find dy over dx. Right?
Yes.
So we just have to be careful. If any formula is applicable, then we must apply the formula. Okay, let's continue. Any confusion so far, Annapurna?
No.
Now we will be discussing about exponential and logarithmic function. Okay, exponential and logarithmic function. So basically, now we are going to talk about logarithmic function. Then we will be talking about exponential function. Okay, so in class 11, in your previous class, you have learned the concept of like all the special functions, that is modulus function, that is greatest integer function, signum function, uh, identity function, constant function, polynomial function, rational function. So here in like those functions are still there, but there is inclusion of two more functions, that is logarithmic function and exponential function. Just a second, let me take few cases, few examples. So basically, the way there, first we need to understand how, like, what exactly is this function. Okay, how the function is defined, that we have discussed over there. Okay, I am not discussed with you, but that you have learned already. And apart from that, you have learned the graph, how the graph behaves. Apart from that, you have also learned that what is the domain and what is the range of that particular function, right, Annapurna?
Yes.
So here also we will be talking about these things. So whenever we are having logarithmic, suppose we are having log n base a is equals to x. Okay. Suppose we are having log n base a is equals to x. This can be written is in exponential form. Okay. From logarithm to exponential form, we can convert it. And do you know, Annapurna, what to write when we want to write this logarithmic equation in terms of exponential equation? What to write?
N log A.
N is not the power. Okay, n is not the power. If it will be the exponent, then we can write it in front. Okay. Now we can write a to the power x is equals to n. This is how we write logarithm to exponential. Logarithm exponential. And reverse way also works. The reverse way also works whenever we are having this type of exponential equation. Then quick, we can write it in logarithmic form like this. You have to be careful how we are changing it to exponential form. Whatever is the base, we call it log n base a. Do you know, Annapurna? We pronounce it like this: log n base a is equals to x. Right, Annapurna?
Yes.
Okay, so whatever is base, that base has taken the exponent. Whatever the other side, there is a term, number, value, variable, whatever is there, the base will take that part as a exponent, and whatever is there along with the log, that will be sitting on one side. This is how we convert the logarithm to exponential form. Okay, now
Yes.
let's see few examples. Suppose we are having, why we do so, so for example, suppose we are having log 8 base 2 is equals to k. Okay, why, what's the need of converting the logarithm to exponential form? So if we will be able to write it in exponential form, just like the before part, the part which we discussed now, and we discussed that whatever is base, that will take the power from the other side, and 8 will be there. Yes or no?
Yes.
Okay. What's the need of writing it in exponential form? Can you see now it is possible to take out the value of k, Annapurna?
Yes.
Okay. How? What will be the possible value of k, Annapurna? 2 to the power
Cube.
k is, yes.
3.
So we can write this 8 as a 2 cube, and we are not cancelling. No, we are not cancelling. We are comparing both side, and we are saying k is 3. So previously something which was not, like, it looked like how to proceed. which that became very simple, right?
Yes.
Okay, and we are comfortable with exponential law of exponent chapter. The whole chapter you have done in, like, maybe I think in class 9 you have you started learning the concept of exponents. So there you have learned and solved so many questions which is based on the exponential equation we are having. So we know how to deal with exponents and all. That's why we are changing logarithm to exponential equation, and then we are solving it. Okay, let's continue. Now suppose we are having, let's say we are having log and base 2. Okay, and again we are having log and base 4. Okay, now we are trying to understand that can we take any number as a base in this logarithm, which we are calling it as a function. Now we will be calling this logarithm as a function where input is n and output is x. A also we can see over here. Now the question is, can we take any number for n? Okay, what will be the possible, what will be the possible input, what will be the possible output, and a, which we are calling as a base. That base can be any real number. Okay, so we are trying to understand this logarithmic function at first. Let's try understanding. So suppose we are having log n base 2, and we are also having log n here. For the other scenario, the base is changed. Okay, now for the first case, suppose you are taking the second, yeah, suppose you are taking n as a 4, and for the second scenario still you are taking the same input n as a 4. Now we will see what output we are able to generate. Okay, so log, if n we are taking as a 4 and here base is 2, do you know how to simplify it, Annapurna, by using the property of logarithm? Can we write this 4 as a 2 square? Can we?
Yes.
So log base is 2, and we are going to write this 4 as a, this 4 as a 2 square. Now whatever you said initially, that power will come in front, right?
Yes.
So let's bring the power in front. It will be 2 and log 2 base 2, right?
Yes.
Which is nothing but 1, right?
Yes.
So result is 2, Annapurna, right?
Yes.
Okay. Now if we have taken n as a 4, what will be the result? What will be the result?
4 log 2 raised to.
Can we see log 4 base 4, log 2 base 4? Directly we can write 1.
Yes.
So what are we noticing the pattern over here? That even if the input and value we are taking same, but the output became different due to the base. That's why base matters over here. Are you realizing that base also matters over here?
Yes.
Okay, so when we are talking about logarithmic function, always we will see what is the base. Okay, base matters. If even if the inputs are same, output can be different due to the base. Okay, let me define this logarithmic function. Let me check any else, like any other example I can add. Just a second. Yeah, few more examples to build the concept. So again, I am writing log n base a is equals to x. Okay. Now here there is a restriction since base also matters and the input also matters. Okay, so there is a restriction which says that whenever we are having logarithmic function which is defined like this, here the base a should be bigger than 0, and also bigger than 0 means any number bigger than 0, but we will not take the base as 1. And apart from that, n also, n is the input that matters, so n must be bigger than 0. Okay, now why so many things are defined like this? If we will be taking the base any number as a negative number, will it not be possible to convert it in exponential equation and to solve the equation the way we did initially? Let's check it. Okay, why it is defined like this, why it says that a has to be bigger than 0. So for that we can take one example. Suppose we are taking, for example, suppose we are taking log 2 and base is negative 2. Okay, is equals to x. Let's try solving this equation the way we did by converting this one in exponential form. So we can write whatever is the base that will take the power from the other side, and that is equals to 2. Yes or no?
Yes.
Now you tell me, is it possible that minus 2 to the power any number is just 2? Just
No.
it's not possible. Okay, that's why we say that the base can't be negative. It can't be negative. But here it's written that it can't be 1 also. Why it's written like this? Let me take one example by taking 1. Is that even possible to take 1? Just a second. If we will be having log, the same example, if I take 1 base 2, log 2 base 1 is equals to x. If we will try converting it in exponential form, what are we going to have on the Annapurna?
2 equals 1 base x.
1 to the power x is equals to negative. Is it possible any time that 1 raised to the power any number, take x as a anything? Is it possible? Is it
No.
possible or not? Okay, so that's why there is a foundation that the base must be bigger than 0 but not 1. Anything but not 1. And there is a foundation on n also, n has to be bigger than 0. Let me check any example which can be taken for. Okay, before even without example, if I try explaining is log n base a is equals to x. That means n is a to the power x. And we are saying that n will always be larger than 0. Whatever you take a we are going to take, we know the foundation on A, we know there is a criteria on A, that is A must be larger than 0 and A must not be equals to 1. Now you think about it. You think about it, if you will be taking any number larger than 0, anything, decimal number, non-decimal number, like a whole number, integer, anything you will be taking for A. Let's say you are taking 2, okay, and the power x, you are, maybe you are going to take the power x as a, let's take negative power. So anytime n value will be negative, anytime, even if the power is negative, will it be negative, Annapurna? 2 to the power
No.
minus 1 means 1 by 2. So even though we are going to take the power negative, the result will not be negative anytime. Yes or no?
Yes.
Why? Because a we are taking bigger than 0. So how? It's not even possible to get the n as a negative number. Yes or no?
Yes.
Okay, that's why the criteria, that is when we are talking about the logarithmic function, here the base and the input n, both will be larger than 0. Okay, and along with that there is a condition that a will not be equals to 1. Is it clear so far, Annapurna?
Yes.
Okay, let's continue. Now this time you have not memorized it, that a has to be bigger than 0, a must not be 1, n has to be bigger than 0. You have not memorized. You have understood the concept that yeah, it's true, right?
Yes.
Okay. Now let's focus on just a second. Just a second. Just a moment, Annapurna. Okay. Okay, Annapurna. So if this much is defined over here, can you tell me what can be the possible, like what is the possible input for this logarithmic function? Think about it and let me know. Can you hear me, Annapurna?
Yes,
What is the, like what can be the possible input which we call it as a domain of particular function?
all whole numbers.
Whole number, whole number starts from zero. Zero is acceptable for the input and see
All positive numbers.
exactly. So we will be saying that real number starts from zero open interval to infinity. Yes or no?
Yes,
Okay, so yes, these are the possible. This one is the domain of our logarithmic function. About range we will be talking, but let's plot the graph at first. Okay, let's plot the graph with the like basic knowledge which we are having. Maybe in class 9 you have learned how to plot any basic graph by making the table. So here also let's try plotting the graph. Just a second. Just actually so much information which you will read it from your NCRD. You will end up getting confused what exactly it's talking about. So I'm just checking the easiest possible way which can be taken over here, which will like help us creating the concept, and you will be able to understand the concept in a better way. Search next. Okay. So at first we understand whenever we are having logarithmic function, we understand whenever we are having logarithmic function, log n base a is equals to x, n must be bigger than 0, a also must be bigger than 0, and a should not be 1. Now here we will we will be having two cases, okay, based on the value, based on the range, like based on the interval of a, we will be having two different graphs. different cases, case 1 and case 2. So case 1 we are going to take a must be bigger than 0. So let's take a is lying in between. A is bigger than 0 and is smaller than 1. Okay. And the other scenario we are going to take, let's take a is bigger than 1 because a is not 1, right?
Yes.
Okay, so these are the two scenarios we are going to discuss about. Okay, so the way A is defined, the base is defined over here. Always, we'll be talking about two scenarios, two cases. Okay, basically two cases. We are dividing it in two cases and then we will be starting our discussion of graph. So at first, let's take the case that is A is bigger than 1. A is bigger than 1 and let's try plotting the graph. Okay, so still we are having the same function logarithm of this the same. If we will try making the table, if we will try making the table, let me take one logarithmic function log x base 2. This is also logarithmic function, yes or no? If we are talking about the
Yes.
scenario that is a bigger than 1, we can take a as a 2, right, Annapurna, and we will see
Yes.
how exactly the graph is moving, right?
Yes.
Okay, so let's take this logarithmic function. Okay, y is equals to this we are having. Now x input, y output. Okay, so if we'll be taking x as a 0, y will be 0 is not acceptable. If we will be taking x as a 1, y will be log 1. What is the value of log 1,
0.
Annapurna? 0. Okay, if we will be taking x as a 2, what will be y?
4.
2 base 2 is 4. Annapurna, log 2 base 2 is 1, right?
Oh, yes.
Right? If we will be taking purposefully, I am going to take even numbers so that we can write it in powers. And if we'll be taking 4, the base is 2. If we'll be taking 4, so 4 can be written as 2 square and the power will come in front. So what will be the output?
2.
2. If we will be taking 8, then output will be
3.
yes. Let's make the graph. Yeah, let's continue. Let's try making the graph. X-axis, y-axis. Okay, 1, 3, 4, 5, 6. Since 8 also we are taking, so I'm extending 7 and 8. Here, 1, 2, 3, 4, and 8 will be 8 is not enough. Okay, only the output are this. If we will try locating the coordinates 1 comma 0. Okay, when input we have taken x as a 1, y came out as a 0. So this is the point, right? Annapurna?
Yes.
Comma 1. So okay, 4 comma 2. When x is 4, y is, this is the point, right? 8 comma 3. This is the point, right?
Yes.
Let me check what will be the result when we will take x over here, over here, here, exactly here. That means 1 by 2. Okay, if we will be taking x as a 1 by 2, what will be the y? Let's take x as a 1 by 2. Annapurna, please tell me what will be the y value. X is a 1 by 2. Can we write this 1 by 2 as a power of 2 to the power anything?
-1.
That minus 1 we can pull in front. So log 2 base 2 we will be able to create. Minus 1 will be the result, right? Annapurna,
Yes.
let me write it here. If we will be taking 1 by 4, then can be written as 2 to the power minus 2, right?
-2.
Let me locate it. When we have taken 1 by 2, that means 0.5. The result came out as a -1. So here. When we have taken 1 by 4, that means somewhere very close to 0. Here the point is 1 by 4. There the result came out as a -2. So here, let's join them. You see the graph on the
Yes.
graph will move like this. So from now onward, whenever anybody will draw the logarithmic graph like this, you are not going to get confused, right?
Yes.
And this is for which what base? When base is bigger than 1. The graph is touching the x-axis at which point? At 1. Yes or no?
Yes.
Any confusion?
No.
Here I here you must be clear that instead of base 2, even if you will be taking base 3, base 4, base 5, base 6, if you will be taking x as a 1, the y will be 0. Yes or no?
Yes.
Okay. So whatever be the base, if that is bigger than 1, then the graph is going to intersect the x-axis at 1. Right? 1 comma 0. Right?
Yes.
Okay. So this is one of the scenario. Let's draw the table for the other scenario. And let's try making the graph. For other scenario, we can take, let's take log. 1 by 2, because a is lying in between 0 to 1. So accordingly, we are taking the logarithmic function. This is the function we are having. Y is equals to log x base 1 by 2. Is it making sense, Annapurna?
Yes.
Okay, here x, here y. Let's try taking. Let's try taking. If here also we will be taking x is a 1. Oh, 1 is not possible. 1 is not possible. Okay, x we can take 1, because a is, the condition is based on a, so 1 we can take and we can check how exactly the graph is going to be. So here also log 1 will be 0, right?
Yes.
Okay, now if we will be taking x is any other number, like 1 by 2, here also we can take. So log 1 by 2 base 1 by 2 will be, yes Annapurna, log 1 by 2 base 1 by 2.
1.
Is it possible to take 1 by
No.
2? Why not? Why? We can take 1 by 2, right?
Yes.
Condition is and must be bigger than 0. 1 by 2 is bigger than 0. Is it so?
Yes.
So why not we are taking? We can take it. Okay? And the result will be 1. Let's take any other number. Which number you want to take? Please take it. If we will be taking x as a 2, then is it possible to calculate? Is it possible to calculate something like this? Log base is 1 by 2. X we have ended up taking 2, and we are trying to figure out how exactly the graph will move over here. So let's try. Do you know change of base rule? If we are having log a base b can be written as, if you want to introduce a new base, you are allowed to introduce. You can introduce log c, a will be here, and if you want to change the base, you are allowed, and here b will be here. This rule have you seen, Annapurna? Change of base rule.
Yes.
So can we apply this rule over here? Can we apply? Let's
Yes.
introduce a new base, and that base we are going to introduce as a 2 only. Okay, 2 we will be introducing. New base is 2. So new base which we want to introduce, that is 2. New base which we want to introduce, that is 2. Now in the numerators part we will be writing this 2 as it is. In the denominators part we will be writing this 1 by 2. Yes or no?
Yes.
So this is coming out as a 1, and this will be 2 to the power. This will be log base is 2, and 1 by 2 can be written as 2 to the power minus 1, right?
Yes.
So what is the final answer, Annapurna?
-1.
When we are going to take 4, then still we'll be able to use the same concept. Okay, log 1 by 2, and here 4 we are having. Okay, let's introduce the base as a 4. Let's see, it may work, it may not work. 4 4, and here we'll be having 4 1 by 2. No, still let's introduce 2. Okay, now it makes sense, right? What are we going to have in the numerator, Annapurna?
2.
In the denominator minus 1.
-2.
If we will be taking 8, then still is it possible? So this 4 I am going to make 8 now. Right?
Yes.
So in numerator it will be 3, right?
Yes.
Denominator it will be minus 1, right?
Yes.
Minus 3. Right, Annapurna?
Yes.
Let's try making the graph. Let's see whether now also it is possible or not with the very basic concept which we are using. With the help of that basic level concept, is it possible to plot the graph? So 1 comma 0, let me mark it. 1, 2, 3, 4, and 8 is somewhere here at last. Here we are having 1, 2, 3, 4. Here we are having downside minus 1, minus 2, minus 3, minus 4. Okay, like that. Let's locate the points. So the first point is 1 comma 0. This is the point. Right, Annapurna?
Yes.
Next point is 1 by 2 comma 1. 1 by 2 is somewhere lying over here. Okay, and when x is 1 by 2, y is 1. So the point is here. Yes or no?
Yes.
Okay, when x is 2, y is negative 1. Here, right?
Yes.
When x is 4, y is negative 2.
Yes.
Here, right? This is just the rough sketch. Why rough sketch? Because the distance between 0 to 1, 1 to 2, 2 to 3, 3 to 4, I have not maintained it same, right?
Yes.
When x is 8, y is negative 3. So somewhere. So briefly we are getting the idea. If you will join. Can you see this is how the graph is? Can you see another one?
Yes.
Okay.